Hello everyone, I'm Ruchi Sharma. In our last video on index laws, we learned all the rules of indices. And now in this video, we will learn how to apply those index laws in solving algebraic expressions which include index numbers. Here on the board, you can see there are various questions and we have to now simplify that using our indices laws. So look at the first one. The first one here is y to the power 3 times y. When there is nothing, no power written, means it's taken to be 1. And then times by y to the power 6. So you can see there are 3 index numbers in multiplication and each of them have the same base. And when the base is same, then the first indices law tells that the powers can be added. So in this case, this is y to the power 3 plus 1 plus 6, 10. That's the answer here. Right? Come to the second one. In the second one, it is m to the power 6 divided by m to the power 5. Now this is your second index law, which says that if you have two index numbers with the same base in division, then you can take the denominator at the top by flipping its sign. So the plus 5, which is there in denominator, will become minus 5 in numerator. So this is now m to the power 1, and we don't write power 1, so it's sufficient to write m here. Now coming to the third question is a cubed whole to the power 4. So what do we see here? Here we see that there is something in the bracket which has a power, and outside the bracket also you have a power. So this is power to the power rule, and the rule says that anything which is in the bracket with the power to the power, then the powers are multiplied. So this is a to the power 3 times 4, and 3 times 4 is 12. So this is a to the power 12 here. Yeah. Now coming to this one. Here if you see, this is an index number, but it has a coefficient as well. And this also has a coefficient as 5. But the sign in between them is a multiplication. So we are in a way multiplying the two numbers. So when we do that in index numbers, the number is multiplied to itself. You know, the number to number you can times, and then you apply the rule on the index numbers to index number. So in this case, it is 7 times 5, and then m to the power 5, and because the base is different here, so you cannot do anything. It will remain like this. See, because the base here and here is different. Here you have n to the power 5, here you have n to the power 7. So the rule can be to club them if either they have the base same or the power same. But in this case, neither of them same. So this will be 7 times 5, which is 35. And m to the power 5 and n to the power 7. That's the simplified answer to this expression. Coming to the next one. This one is, again, something is written in the bracket and everything is to be powered with 3. So when we do this, this means when we open the bracket, then every number inside the bracket, every term individually, 4, p, q squared, is being powered to 3. So this is 4 to the power 3, because not writing any power here means the 1. It is 1. Not writing means it's understood to be taken as 1. So this is now 4 to the power 1 times 3, which is 3. P to the power 1 times 3, which is 3. And q to the power 2 times 3, which is 6. You get it? And then 4 cubed we know is 4 times 4 times 4, which is 64. P cubed, q to the power 6. That's the simplified answer. Come to question 6 now here. Similar type. Just as you solve another fraction. So this is actually 4 times 6 divided by 3. consider them just as numbers because this is multiplication and division in between. So one way is you go top to top and you multiply that and you write this as 24 over 3, and then you add the powers because this is m squared multiplied to m to the power 7. So you can actually write it as m to the power 9 and keeping m to the power 6 in the denominator. But then the other rule says that if you have the same base and the index numbers are division, they are coming in division, then you can also write it, and this also 3 and 24, it cancels at 8. So this is 8 m to the power 9 minus 6, which is 3. So this becomes the answer here in this case. Yep. Now this one looks so big, so many p's and q's are here, but simple rule is the same, that whatever p comes in the multiplication, you have to add the powers, and if there is a p index number in division, that power you have to subtract. So let's start step by step. So this is p to the power 5 multiplied to p to the power 12. So this is p to the power 17 because you added the powers. Then there is q to the power 3 and 8, which is together because they are again multiplied, so you can add up the powers and make it 11, over p to the power 10 and q to the power 4. So now this is p to the power 17 over p to the power 10, which is now, when you do the minusing, p to the power 7, because 17 minus 10 is 7. Similarly for the q1, it's 11 minus 4, so it's 7 again. And if you want, this is again the correct way of writing, but if you notice, they both are different base with the same powers, so you can actually write it as this as well. That is also correct. Yeah, let's go over this one more time. So this is p to the power 5, q to the power 3. When we are not writing anything, means there is a multiplication in between. Just as when we say 2x, means what is the relation between 2 and x? They are in multiplication. So similarly here, it's p to the power 5, q to the power 3. It's a multiplication, not written, but understood. Then multiply to p to the power 12, q to the power 8, divided by p to the power 10, q to the power 4. Right? Now, p on the numerator, you're going to club them. So this becomes p to the power 17. 5 plus 2, 12 is 17. And then q to the power 3 plus 8 is 11. Then divided by, as it is, this expression, p to the power 10 and q to the power 4. Again now here, p to the power 17 is divided by p to the power 10. So the rule says that if the same base you see in division, then the power, the bottom power can go in minus. So this becomes p to the power 7. And then q to the power 11 minus 4 is again 7. Now, because both of them, p and q, have the same power, so we can actually club them in the bracket and write pq whole to the power 7. That can be one of the way of writing, but even if you leave it here, that's fine. That's the way correct. Okay, let's do some more questions here. Yeah, few more. Yeah. So now this one, again, division. You know the law, and you can see both of them have the same base. So one way is if you want to go step by step, then you can write it as 3 over 2 to the power x and 3 to the power y. And then by the rule, because the denominators, the base are the same and they are in the denominator division. So this is the power comes, the y flips, goes at the top in negative power. So this is one of the way of doing, or otherwise the division sign automatically tells you that it is here like this. So what you are dividing the number, the power goes in minus. So you can straight away also could have written it, but that's all right if you want to do one more extra step in between. Now coming to this one, this is a little tricky, yeah, little, but let's see. The division again means the same. So one way is you write it again this way, 5n and the other way is you could have actually used this division sign, knowing the rule that now the power here will go in negative. So this could also have been written straight away as minus of 2n plus 1. Now, the point to be noted, and be careful at this point, that when you are putting a negative, the negative is with the entire exponent, this power, the entire part. Don't make an error of just putting the minus with only 2n and keeping your plus 1 as plus 1. No. This minus, when the sign is changing, it is changing with the entire power, the entire thing. Now, when you open it up, this is 2 to the power 5n minus 2n and minus 1. Just simplify it. So this is 3n minus 1. So this is the answer to this expression. Yep. Coming to this one now. Again, same thing. The rule is same. You can see this is a whole to the power minus 3. Everything in the bracket is being powered. So this means each of the term in the bracket is being powered to minus 3. Let's write it. So this is 2 to the power minus 3, p to the power minus 4 times minus 3. So this is 2 to the power minus 3. When you have a negative index, negative power, you can make it positive by flipping it. So this is same as writing 1 over 2 cubed. And then p to the power, when you multiply a negative 4 to negative 3, when two negative numbers are multiplied, it's a positive answer. So this one is 12. And then 1 over 2 cubed is 8. So this is p to the power 12 over 8. That's how we write it. Yeah, I'll just make a line so that you don't get confused. Let's just end it there. All right, now come to this one. Same approach. All these numbers, we don't write a multiplication, but this means it's a 5 multiplied to a squared multiplied to b to the power minus 11. So this together is one expression, and this together is one expression. But in between each of these values, it's a multiplication. And now when we multiply these two, to simplify further, the number is multiplied to number. So this is actually, you can, if you want to write 5 times 3 separate, and then a terms, if you want, you can bring them together, then b terms together. Now 5 times 3 is 15. Then because they are the same base, the powers are added. So when we add it now, be careful, it's 2 minus 3. Because plus minus is minus. So this is 2 minus 3 times b to the power minus 11 plus 7. That's how we write it. So this is 15, a to the power minus 1, b to the power minus 4. That's the answer. Yeah? Let's do it again. So this is 5 times 3, 15. A squared, a to the power minus 3. Base is same. It's a multiplication in between, so the powers are added. So this is a to the power 2 minus 3. Then b to the power minus 11 plus 7. And then it's a to the power minus 1 and b to the power minus 4. Now this one, 16. This is interesting to do. If you see how to proceed, what to do. But if you look at the power, it's a quarter, 1 over 4, a fractional power. How to deal with it? When we look at 16, is there any number? Can you write 16 in a way that it has a power 4 involved? Because this is a quarter is the power here. But we can write 16 as 2 to the power 4 and whole to the power quarter. Look at this. This is a bit difficult, but let's think about it. Because this is a power which is in fraction, a fractional power. So from where to proceed with this kind of an expression, how to simplify it? So we will try to write 16 as a number, as an index number, which has a power 4. And we know 2 to the power 4 is 16. So we can write 2 to the power 4 and whole to the power a quarter or 1 over 4. Now this is the rule that when you have something in the bracket to the power something, then the powers are multiplied to each other. So this now becomes 2 to the power 4 multiplied to 1 over 4. And what is 4 multiplied to 1 over 4, or 4 times a quarter? That's just 1. So it's 2 to the power 1. So the answer here is 2. Yeah, let's see it again. So 16 to the power 1 over 4. Because this is the power, which rule do you think we can do? This is not a negative power. You don't have 2 index numbers. It's just one simple index number. How to simplify it? So think of, it doesn't have negative power. You can't flip, you can't do something like that. So which rule do you think can be applied here? So one rule could be that if this is quarter, power is 1 over 4, if only we are able to write 16 in terms of a number which has the power 4, or we are able to write this in the index form, that's a reverse. So this becomes 2 to the power 4 and whole to the power a quarter. Then the rule says something to the power, a power to the power is multiplied. So this is 2 to the power 4 times a quarter. And 4 times a quarter is a quarter of a century is 25 runs, and 4 times a quarter is 100, the complete century. So this means 4 times a quarter is 1. So you have answer as 2. Yeah. So I've tried to cover each of the rules, the laws which we learned in our last video. I've tried to bring one example of each type minimum, but we'll be doing more on these. In the meantime, you practice and you can have a re-look at these videos, and do ask me if in case there is any doubt. Just write in the comment box, and I'll be doing more questions with you then if in case needed. All right, bye, take care.